We'll start right away. Okay, let me share my screen. Share. Hmm. Can you guys see my screen? All right. Thank you. Huh. It could be like a kind of repetitive. And okay, start solving this problem one by one. So number of literals and variables in the simplified form of f. Let me fix this. Is the recording on? Great. Hmm. Literals, how many? Variables, how many? In the simplified form. Anti-protection. I don't need that. Who is that? Okay. Okay. Whoever has got the answer, you can put it in the chat box. Whether which option is the right answer. Any answers? X y plus y z w plus x bar z. Hmm. 4 variables. Okay. Which option? How many literals are there? Okay. Let me pick up these people. I want to see whether these people are alive or no. Okay. Hari Prasad, are you there? Now, what's your answer? I don't know. Okay, fine. No problem. Parth Sardi. Okay, I'll explain that. I'll explain that. Yes, Parth Sardi. Unmute yourself and then talk because this is for interaction. This is not for one-way communication. So I'm just interacting. Okay. Hmm. Option D. Okay, all right. Four literals and four variables. Okay, all right. Great man, great. Please interact, okay? In the future also. Then Prabhat, I think he interacted. Okay, Sai Swati, what's your answer? Okay, all right. Great. Neetu? Okay. And see, okay, all right, got it. So don't worry whether the answer is right or wrong. Here we are here to learn. And also this class is not about solving simple problems. This is about miscellaneous problems, right? So you see one thing. First, let's understand what is a variable, what is a literal, right? And we already know. See, if you look at this f, you have x, y, z, w, z, x, right? Means I can write f as a function of x, y, w, and z. Hmm? This is xy plus yzw plus zx bar. Hmm? Means looks like. Okay. Looks like there are four variables. Looks like. But the question is here, the simplified form. Here is the tricky part. Can you able to reduce this Boolean expression? Of course, this is not the right answer anyways. Can we reduce it? So it looks like there is nothing to reduce, right? But one thing you need to remember, there is something called consensus theorem. What is consensus theorem says is, okay, oh, let's understand literal also. Okay, what is a literal then? Hmm? We understood variable, very clear. What is a literal? So, a literal is nothing but x is a literal, x bar is a literal, y is a literal, y bar is a literal, z is a literal, z bar is a literal, w is a literal, w bar is a literal. Okay. If a function has four variable, possibly, then literals will also be eight, possibly. I am saying. How many? That depends on the simplified form, depend on the question, right? So let's look at the question. Hmm. So consensus theorem, what it says is, if a Boolean expression is in this form, a p1, a bar p2, p1 and p2 is equal to a p1 plus a bar p2. This is a consensus theorem. Proof is very easy. I don't want to solve it and then very easy, straightforward. Okay. Now, what you need to do is, before you say this is a simplified form, before you utter that phrase, you need to cross check the consensus theorem. Whether can I apply consensus theorem to this particular equation or not? Still, if you are not able to find out, then you can say that this is the simplified form. Now, can you guys tell me, can I say f a simplified form, or is there a possibility of applying a consensus theorem in that? You can unmute yourself and then talk, no problem. As I said, it's an interaction, right? Is there any possibility of applying consensus theorem? Yes? Okay. So after simplification, I mean, how to apply consensus theorem in this? So it's look like A, P1, A bar, P2, and you also have P1, P2. it is not exactly applicable, but what you can do is you can apply in the reverse way. See, uh, let me erase this. Right now, you got the understand, right? This is a little bit tricky. That's why it's miscellaneous. Little tricky. What you can do is f is, I can write it as xy plus x bar z plus y z w. If it is just xy plus x bar z plus yz, then right away I would have eliminated this and then I would have written the final answer and then I would have told this is the simplified form. This is not the case. Little bit trick is there. Okay, just focus on it. So what is that we can do is this. See, if this is LHS is equal to RHS, and we can also say RHS is equal to LHS, right? If see this is present on the RHS. For this, I can write LHS form. What is that I can write? XY plus X bar Z plus YZ. Can I write like this in the reverse way? Yes or no? Plus, I can write the same thing as it is. Right? Now we know what is this YZ plus YZW. How can I write that? YZ plus YZW can be written as YZ if I take common 1 plus W. 1 plus W is 1. It is YZ. Right? If I combine these two, what will happen? XY plus X bar Z plus YZ. Now this is exactly in the consensus theorem form, right? So I can write this one as XY plus X bar Z. So this is equal to xy plus x bar z. So how many variables are there? What are the variables that are present in that? Okay, let me write. I'm messing up here. No problem. X you have, y you have, z you have. Literals. Hmm? Let me use some other color. You have x is a literal, x bar is a literal, y is a literal, z is a literal. Okay. So if you count, you have three variables and four literals. So the answer is what? Literals and variables. It's a reverse way they are asking. Literals how many? Four. Literals four. Variables three. 4 comma 3. So option B is the right answer. Any questions? Understood? Yes or no? Just type it in the chat box. Right? So that's where we need to little bit apply. And I'll tell you an extension to this. Okay, it doesn't end here. There is one more form, right? Dual form. So you know the dual, right? So if I say, before I say about duality, I'll just take this example, which is very, very basic. People know this already. You know, A plus A is A, right? I mean, A plus means RA. Then this is A plus A complement is 1. Similarly, A and A complement is 0. Correct? And A is A. Are you getting it? Similarly, I can write A plus 1 is 1. A plus 0 is A. Right? Simple thing. These are the things which you know already. A and 0 is 0. A and 1 is A. Now, what is the duality says? Duality theorem. This is very, very important in the entire Boolean algebra. F and G is not equal, okay? Are said to be dual to each other, right? Or G is said to be F. when the AND operation in F is replaced with OR operation is replaced with AND operation, 1 is replaced with 0, 0 is replaced with 1. Then you obtain the dual to F. Similarly, you can obtain the dual from G. Anything is fine. Sir, what is the proof? You can look at this, okay? Take this example. A plus A is A, right? This is a proof. If you replace this OR operation with and A is A. Is it true or not? True, correct? Then second proof, I will give you multiple proof. This is already there here. You take this one, take this guy. A plus 1 is 1, right? Now according to duality, what you should do? This replace with AND operation, replace with 0. This you cannot do anything, A and 0. This replace with 0. Perfect. This is also true. That means that any expression that you take, it will have its dual. And you don't need to again think whether this is proved or not. Anything you take that will be proved. Correct? You take this example. A plus A bar is 1, right? A plus A bar is 1. Now this you replace with a dot. This is A. This is A bar. What if you replace this with a 0? This is also true. Means if you know one form of expression, obviously you know the dual. You know their dual. Correct? Similarly, for consensus theorem, you have this xy plus x bar z plus yz is what? Xy plus x bar z. Whatever you have seen. Now this I can also obtain the dual x plus y. Wherever dot is there and will be there. Wherever and r is there and will be there. X bar plus z, y plus z is equal to x plus y into x bar plus z. So for consensus also the duality will be there. You understood? So maybe they may not ask you this question directly, they may ask the other one, the duality, the dual one. Because that's how people are little less familiar when compared to normal terms. Right? Right? Okay. We'll move on. Okay. Find out this the Boolean expression for the shaded region. Which Boolean expression describes the shaded region? So I want you guys to interact more and ask more. Option A, okay. Okay. So if I take the simple logic, right? Let's say this is universal set. Hmm? In that A is there, for example. This is A. So if something is present inside, what do you say? That belongs to A. What about this region, which is outside of A? It is not A, correct? Or not in A. Means I can say it is A complement in a sense. So, if you look at this region, okay, let me change another color. If you look at this region that is highlighted here, this region is present in A and not present in B and not present in C. Am I correct? Right. And if you look at this region present in both B and C, but that is not present in A. And for the entire area, shaded area, I can write A B complement C complement plus A complement BC. So option A is a correct answer. Somebody answered it, I think. Yeah, correctly. Any questions here? Shall we move on? I think this we can discuss more in detail when we see this. Any questions? Okay, fine. This we can discuss in detail when we go to K-maps and all. That will be super easy there. Midterms and all we'll see there. Huh. Which of the following is true for Boolean algebra and not valid for ordinary algebra? Option C. Yes. If anybody has any questions, I can explain. Otherwise, I'll move on. Just take some numbers and then put those numbers. Like A equal to 1, B equal to 2, 3, C equal to 3, and then substitute. Okay? And by the way, these two are duals to each other, right? These two are duals. If anybody want me to explain, I'll explain. Otherwise, move on. We have a lot of problems are there. Next. The Boolean function AB plus A bar C is written as A plus M into A bar plus N. Which of the following is true? C. Okay. Okay. So according to this problem, right, AB plus A bar C is written as A plus M A bar plus N. Hmm? Right. So let's look at the right hand side. What is there in this? Okay. This is just multiplication again, not the operation. A and A bar, right? A and A bar plus A into N. This is M into A bar into N plus Mn, right? This is evaluated. So what is there? An plus A bar N plus Mn. We know already. Just know this one, right? AP1 plus A bar P2. You see this one? Consensus theorem. Similarly, right? This is like AP1 plus A bar P2 plus P2 P1, right? Okay. So I can remove this. This is redundant term, right? So this is A n plus A bar n. This is equal to AB plus A bar C. That is straight no, equations. B is nothing but n. C is nothing but n, right? C is n. B is n. Hmm? So M is C, N is B. Correct? Huh. X bar plus Z, X bar plus Z bar, X bar plus Y plus Z bar can be reduced to dash number of letters. Prabhat Kumar is saying 4. Okay, let's see. The same one. Okay. See, one thing you need to keep in mind, right? This is distributive law, right? A into B plus A into C. Similarly, there is something called as dual to this. A plus BC is equal to A plus B into A plus C. Okay? Hmm? Here, if you take this x bar plus z into x bar plus z bar into x bar plus y plus z bar w. If you take these two terms, right? This is like right hand side, right? You look at this. A plus B into A plus C, something like that. If you combine those x bar plus z at z complement, x bar plus y plus z bar w. Z complement is 0. Then x complement plus 0, x complement plus y plus z complement w. Again, you see these two are same, right? Like a plus b into a plus c is a plus bc. So x complement plus, here this is b, this entire thing is c, right? 0 into y plus, this is your final expression. 0 into everything is 0, x bar. So 1 is the right answer. Okay, let's move to next. What is 7-bit 2's complement representation of 43? Any answers? Any answers? Mhm. Option D. Okay. So very simple. You take 43, and we know how to write it in binary weighted form, right? 1, 2, 4, 8, 16, 32, 64, and so on, right? This is 1, then this is 48, then this is around 40, then 0, this, how many bits they are saying? 7-bit representation. How many bits I have? 1, 2, 3, 4, 5, 6. So I add one bit to this. Then what I do? Take one's complement. That means 0, 0, 1, 0, 1, 0, 1. Then add 1 to this. 1, 0, 1, 0, 1, 0, 1. Wrong. Wrong answer. Can anyone tell why it is wrong? So the basic is this. When you take number system representation, you have positive numbers, you have negative numbers. Now, these two's complement, one's complement, and sign magnitude form all are valid only for negative numbers. Positive numbers are like a default. You don't need any representation for that. Just you represent the way they are. If somebody asks you what is representation of minus 43, then you do all this 10, 10, 10. This is right answer. But the question is what? Plus 43 means take the same number as it is. 0, 1, 0, 1, 0, 12. That's it. Option A is the right answer. Are you guys clear? Yes or no? Shall we move on? Okay. Now this one. Now we look at this. Anyways, the topic has come. So if you look at plus 43, what is its representation? 0, 1, 0, 1, 0, 1, 1. You look at the most significant bit, MSB bit, that is equal to 0 if it is a positive number. That is equal to 1 if it is a negative number. Right. Now that is a basic for this question. Two numbers are represented in signed two's complement form. One is this P, then this is Q. If Q is subtracted from P, then the value obtained in two's complement form is dash. Option A, option B. Very good. See, for these kind of problems, let's convert these into basic numbers. Okay. P is what? 1, 1, 1, 0, 1, 1, 0, 1. Right? How to get the decimal number? How to get the decimal equivalent? There is this thing, right? If this is a 2's complement form, again you take the 2's complement, let's say, right? So let me erase the stuff. It will be confusing for the audience. So let me take another slide. Let's say plus 43 is given. You know that you will do, right? So what is it? 0, 1, 0, 1, 0, double 1. This is 1, 2, 4, 8, 16, 32, correct? 32, 40. Okay, that's all right. Suppose if minus 43 representation is asked in 2's complement form. First, what will you do? You take plus 43 representation 0, 1, 0, 1, 0, double 1, and take the 1's complement. So 1, 0, 1, 0, 1, double 0, add plus 1 to this, right? So 1, 0, 1, 0, 1, 0, 1. Similarly, if you somebody asks you 10's complement, take 9's complement, add 1 to this. Okay. Now, you don't know all this. They said some number p is given in 2's complement form 10101001. How to get back to this number? You what you do again you go 2's complement further. Means what? You do 1's complement 0101010, add plus 1 0101011. Since the MSB is 1, we know that this number is going to be negative number and this will give the magnitude, right? So minus, what is the magnitude of this? 43. B, I can say minus 43. Right? Simple. Apply the 2's complement. Right? You observe the MSB first. What I did? I observed this MSB bit here. This is 1. That means that this number is going to be negative. How to find the magnitude? You do the 2's complement. You will get the magnitude. Back. Now here, you observe the MSB. So P is negative number. How to get the magnitude? You apply the 2's complement. First do 1's complement first. 0, 0, 0, 1, double 0, 1, 0, plus 1. 1, 1, 0, 0, 1, triple 0. This is the magnitude. So P is minus of, what is the magnitude here? This is 1, 2, 4, 8, 16. 16 plus 2 plus 1, 19. What is Q? 1, 1, 1, 0, 0, 1, 1, 0. So Q is negative. What is the magnitude? For that you need to find that 1's complement. 0, 0, 0, 1, 1, 0, 0, 1 plus 1 you do. 1, 0, 1, 0, 1, 1, 0, 0, 0. What is this? 1, 2, 4, 8, 16. 16 plus 8 is 24. 24 plus 2 is 26. P is minus 19. Q is minus 26. So, what is the reason? If Q is subtracted from P, okay, means they are doing Q is subtracted from P. P minus Q they are doing. That means minus 19 minus of minus 26. That is equal to minus 19 plus 26 is equal to plus 7. The answer is this. Directly I can say. Why? Because you see this. They are asking the value obtained in 2's complement form. Right? So this is a negative number. This is a negative number. This is a negative number. Only this is a positive number. Otherwise, this is also a 7, right? You can do the otherwise. So whether they ask you multiplication, division, everything, first you obtain the decimal equivalent. That will be straightforward and easy. Are you guys clear? Yes or no? All right. Hmm. Okay. For a number system with radius x is equal to this, then x is what? Option C. Okay. Option B. Somebody is saying. Okay, fine. See this. Let's say there is a number 0101 base 2. How to convert this into decimal base 10? You know, very simple, right? 1 into 2 power 0, 0 into 2 power 1, 1 into 2 power 2, 0 into 2 power 3. Correct? Like this, you will add the weights. Correct? These are called weights. Correct? 2 power 0, 2 power 1, 2 power 2. What is this 2 power 2? 4 plus this is 0 plus this is 0 plus this is 1 that is equal to 5. So isn't okay? 0, 0 decimal equivalent is this. Now you already know the decimal equivalent 18. So this can be written as similarly 1, 2, 3 base x but that is also not right. You see this? If I take decimal number 10, decimal number system, the maximum number that is available is 9. If I take binary, the maximum number that is available is 1. Everything else is a combination. And if I write, say, let's say for example, 3 is the right answer, I'm saying 1, 2, 3 base 3. Are you getting it? It's like saying 0, 1, 2 base 2. 0, 1, 2 base 2 exists in the binary? No. This also cannot exist. So, neither this nor this. So, option D, none. There is no solution exists for this. Okay, are you guys clear? Yes or no? Hmm. Yes. I think there are few numbers here. Questions are there. Okay. Try this. Actually, there are many other questions. So if you want to solve, we can either solve it in the. I think we'll do one thing. Anyways, I crossed 8 o'clock. We can solve the remaining things in the next session. Okay. So if you have any questions to ask me, you can ask me now. I'll wait for 2 more minutes. Then we can disperse.